Hello, everybody. My name is Radoslav Stankov, and I'm coming from Bulgaria. Actually, I'm not coming. I'm here in Bulgaria, sitting right now. And I'm head of engineering at Product Hunt. And today I'm going to talk to you a bit about our React Native architecture and how we have structured our React app. But before we get into the big technical details, for every good architecture, you have to get the context, like where the team is coming from, what the requirements, and how the stuff is built. So Product Hunt is this website. This is how we look on the web. And I have given previous presentations around the Product Hunt architecture. And I won't go into details there, but when we decided to rebuild our mobile app early this year, actually we released it early this year, we started a bit later than that, we were wondering, okay, now we should do a big reboot into our mobile app. And for our cases, we had basically two choices. One was go native with Swift, and the other was go React Native. We really had really terrible experience around more than 2 years ago when initially we started with React Native. It was quite a bit of a challenge. On the other side, we have only 2 developers who have some Swift experience, not very new ones, and we have 0 developers with Android experience. And our app, we needed to run it on Android as well. Also, Apollo, so we use GraphQL for our data transferring, and the best way to use it is Apollo, in my opinion. Apollo for Swift is not as good as Apollo for JavaScript. And our team already knew how to deal with React and Apollo. What the other thing we needed for this app, because was to do like a lot of UI experimentations. And again, we also needed Android. So early in 2020, we were making mobile app experiments for Your Stack. So early in 2000, we worked on 2 apps for a couple of our products and experimentation. One was Your Stack, the other was called Stack Camp. They were both not released because they were just in beta. We tested some ideas there. So yeah, don't tell anybody. So from them, we were able to compare the ecosystems from React and Swift, and we decided to go with React just because we needed Android. Our team already knew React Native, and React Native actually became a lot better than 2.5 years ago. It got a lot faster, a lot more stable, and we didn't have the same issues as we had before. And the tech stack we decided to go was, okay, we go with React and React Native. We use GraphQL, we access it to Apollo, and the table stakes, TypeScript, Jest, and Prettier are basically not of the question if we go with the JavaScript ecosystem. And as everything done mobile, we are using Fastlane for tooling. So the things around architecture is, if you don't know where to start, you can very easily get into the situation where you get stuck. So we want to move fast and have breakfast, not breaking things fast. So we want to move. So for our architecture, we have 4 goals. First is to make the common operations easy. So the engineers can easily add new things. Then we need the good code organization so we can onboard new team members very easily into the code base. Isolate dependencies, like in the JavaScript world and in basically every modern world, we're dealing with external dependencies, and they can very easily get out of sync, out of date, and break a lot of things without our control. And the final thing is extensibility and usability. We want to build things that we can extend and reuse over time. But the most common thing for us is make the common operations easy. So everything a developer has to do their daily day should be very easy for them. And the way I'm thinking about the parts of the architecture, I'm seeing 3 pillars: the support, the components, and the screens. And they look like that in my head. We have a big support area, which helps us build the core reusable components, and then we build the screens on top of that. So for somebody more visual, this is the way you can imagine it. You have the pilots, you put them in the lines, and they make Voltron and make it really nice. So if you go and see our directory, this is how the directory structure of the mobile app looks like. And it represents the architecture of this app. And if you see, if I color code it here, we have support, components, and the screens. So again, talks cheap, show me the code. So let's start with the top layer, because it actually helps us understand the layers above if we start reverse from the screens. So all the screens are defined in the app.js. And here, what we do is we use the React native navigation. We experiment with the others navigation, but this one was the one that fit our working style the best. It's a really good library, and we didn't have almost any issues with it. So this is how our main screen looks like a summarized version of it. So we have this main stack, and we are attaching these screens. And notice that here we are just doing a spread on the screens. So the spread of the screens come from this screens folder, and it's in index. What we do is we just export all the different screens. So we have a central place where a developer can actually trace where their screen is. It's like a map. And for screens, this is how a screen looks like. We basically have a flat list where we on the root, we have the screen name. Then we have a directory where we have everything related to the screen. Like, for example, if in this screen, we have two private components with search and the feed item. So those are components only used in the screen. We have the GraphQL query, the query that will get the data for the screen. We have some utilities, and the index.js is the screen. If we think about the screen is actually a state machine. And this state machine starts with a layout. Then it goes to the loading state inside of this layout. If something bad happens, there is an error state, and this error can be a server error, not found error, authorization, authentication, and similar errors. On the other side, we can have the loaded state. So when the screen is loaded, there is a couple of operations we always need to do. We need to render the screen. And we notice that we have a lot of this state code in our system. So what we did was we extracted an utility we had on the web called create screen. And this create screen allows us to define, okay, what's the name of the screen? So it's very useful for debugging. What's the query which would be used to load the data? What are the query variables for this query? Which is the component this screen is going to render, and we just pass to this component the data and the params. What type of screen this is? In our application, we have three types of screen. A screen which is like a push screen, which we just push it back. We have an action sheet, which just opens like an action sheet. And we have an overlay, which is an overlay. Also, there is a couple of other options like the screen background. Different screens in our system has different background. What's the title in the navigation? And there is this safe area, which is the iPhone X style of no home button, and how do we do in different screens. So every developer can just build a screen with calling this command. So what we have is we have the screen, which is create screen. It goes to the screen index and then goes to the app.